Ambrogio, you're up. ¿Movemos la mesa?
Hi guys, my name is Jack. We come from Italy. We are a group of robotics enthusiasts. We are actually students. We do it for fun. It's a group made of 12 people coming from different fields of study. We have people from electronics. I study computer engineering. We have a few mechatronics. And we came together because we wanted to make a robot. Why? Because making robots is fun. It's a lot of fun. And making a robot is the future. It's what we all wanted to do. Of course, once you decide to make a robot, you need to decide what kind of robot you want to make. So we sat at a table and we told ourselves, okay, we want to have fun, but what if while having fun we also build something that is actually useful to society, that makes something good for humanity? That's why we created this robot. We wanted to make something to help the elderly and the disabled. This robot, which is what we think is the solution to the problem, is Ambrogio. Ambrogio is an Italian name that is usually used for butlers, kind of like James is sometimes in the English language. And we created it to be able to move, to go around, to look, to touch things, and that's why we gave it wheels, a robotic arm, we gave it cameras to see, and we needed to think, of course, of the best way to use all these components. We thought, what if we let people take control of the robot from some other place to actually help people? Like, for example, one use could be letting a doctor check on the health state of his patient from the other side of the world. That would be an amazing thing, and maybe interact and move stuff. So we needed to find a good way to make this robot accessible to everybody, both in easiness, ease of use, and technology. So we thought, what's something that pretty much anybody knows how to use and everybody already has? So we thought that the best way to do this was using a web browser and create a web interface that allows to control the robot. Now, we came up with this. It's basically, you can connect, the robot is running a web server, and you can just connect to the IP address of the robot, and a web interface pops up with a camera. You can see a picture sent from the camera, and you can control the robot. You can, I'll show you in a second. You can move the robot. The robot was brought up here. Of course, we're using a cable because there are lots of Wi-Fi connections around here, so we couldn't achieve a stable Wi-Fi connections, but we can actually move the robot just using the keyboard from the web interface. We can make the robot talk.
Ciao.
It can move around. We can make it do pretty much anything we want. We achieved this via a modular system, because every single part of this robot is independent from each other. We created a system where every part of the software communicates through a central server that dispatches the messages between the various parts. This allows us to use
You've got 4 minutes.
Yeah, using standard web sockets. This means that we can insert ourselves at any point in the chain of programs that's running on this robot. This means I built an Android app on my smartphone that allows me to move the arm from my smartphone. We created the web interface. We could interface basically anything with it. It's a great way to make a flexible platform, something that can actually be used by anybody. Like, who hasn't used a browser in his life? It's very easy to use. We can also add hardware parts whenever we want without the need to rewrite everything that's on the robot. We just need to write something more that already interfaces with what we have. And what we want to achieve at the end is some kind of semi-autonomy We don't want it to be completely autonomous. Apart from understanding basic messages, basic speech commands like fetch this object or move the arm or do something like that. We want it to help humans use it in the most easy way, in the easiest way possible. We can achieve this by preventing errors. For example, when moving in an environment that's full of obstacles, you could risk hitting something and ruining the robot. We are planning to put a Kinect on this, which can help with the use of the 3D camera. It can help the robot navigate and avoid obstacles, thus preventing the user from actually damaging the robot. So this is what we think is a good solution to the idea of telepresence, of the possibility to control the robot from anywhere around the world. We actually have set up a server in Italy. This robot connects via VPN to the server, and anybody can connect to the server and control the robot from anywhere around the world. This allows us to make it use pretty much any connection in the world without having to open ports or do anything too complicated for the standard user. So this is our robot. Thank you.
Thank you. That was 6 minutes. That was great.
I'm just going to call if Eric wants to come here. He's the electronic guy, I'm the computer guy, so if you have any questions regarding electronics, you can answer.
Sure, questions.
How did you arrive at the decision to use cable actuated arm?
Sorry?
How did you arrive at the decision to use cables and servos for the arm?
One problem with using an arm is that the arm can be very heavy if you put motor into joint. So if you delocate the motor on the base and transmit motion with cables, you can make the arm that much less weight, and so it can be much cheaper to use.
Does the hand have any sensors in it?
It's just a gloves. We are starting working on the manipulator.
Well, I'm also interested on the hand, and can we see it working?
I think so.
Full range of the arm.
Is it a project for the university or something like that?
Yeah, we are a students group. We are not actually researchers. We're just students that met and decided to build a robot through our university. Yeah, so we come from a university, but we're not professors or anything. We're not actual researchers. We're just students.
Thank you. No more questions? Thank you. Thank you, guys.
Thank you.
So our next one is Alex, but not sure if they're